Hello and welcome to this episode. We are going to continue our discussion on indexing and slicing of Numpy arrays. And in the previous video, I showed you how to index 1D arrays. In this video, we're going to focus mainly on two-dimensional arrays. So I'm going to go here and then I will create a new notebook, rename it indexing 2D arrays. Okay, so as usual, I'm going to import numpy as np, and then I'm going to generate some two-dimensional array here just for demonstration purposes. And always remember, you can use any of the array generation functions that I showed you in the previous videos. You can use np.random.uniform, np.random.normal, and any of the array generation routines that I showed you can be used here, but for demonstration purposes I'm going to generate arrays on my own. So I'm going to say data is equal to np. In fact, let me create a list, and then I'll use that list to create the numpy array. So I'm going to put 1 2 3, and then I'm going to say 4 5 6, and then I will say 7 8 9. Okay, then I will come here and create a numpy array from this. So I'll say np dot array. I'll pass in the list, and then let's check data dot shape. And as you can see, this is a 3 by 3 array. And what makes us think this is a two-dimensional array is that when we check the endim, or the number of dimensions, we get 2. Okay, now this is very important. The fact that endim gives us 2 indicates that to access any element in the data array here, we need to give 2 indices. In the previous video, we just specified one index to access elements at those given index that we were interested in. But when it comes to 2D arrays, you need 2 indices to access the element in the array. So to help you understand things better, I'm going to use the list up here to show you how to count your rows and your columns. This list here is a list of lists. This is the outer list, demarcated by this and then this. And then inside it are 3 lists. So 1, 2, and then 3. Now in NumPy, every row represents every inner list. So I'm saying this for a 2D array. For a 2D array, every inner list represents a row on its own. So this right here is row 0. Always remember that we count from 0. Even though when you check the shape of this, it's going to tell you 3 by 3, because of course there is 1 row, 2 rows, 3 rows. However, the indices of each of these rows start from 0. So this is 0, this is 1, this is 2. Okay, and if you want to count the columns, you count it vertically. So column 0 is made of 0, 4, and then 7. Column 1 is 2, 5, 8. Column 2 is 3, 6, and 9. But of course, we counted from 0, so we ended at column 2. However, if you count from 0 to 2, you actually count 3 items. That is why the shape of this array is a 3 by 3. So the first number here represents the row, and the second represents the columns. If we move on to 3-dimensional arrays and arbitral or n-dimensional arrays, the first dimension is going to represent something else. But for 2D arrays, which is very common when we are dealing with tabular data in machine learning, the first number represents the number of rows or the number of samples, and the second number represents the number of columns, which is also represented the number of features in each of your training examples. Okay, so now we know that our data array has two dimensions, and so we need to specify two indices to access individual element. And the individual thing I'm saying here, take it as a keyword because it's very, very important. When I say individual, I mean one single value in the array. Okay, otherwise, if you access this whole row, it is not an individual item, it is an entire row. But if I just want to access this 4 here, then it's an individual item. So let's see how we can index this 2D array. If I come and I say data 0, let's see what we get. So data 0 gives us the first row. Okay, data 0 gives us the first row. In the same way, if I do data 1, I get the second row, and data 2 is going to give me the third row. And this is because I specified only one index. If you give only one index, what it means is that you want to access the entire row, because this is a 2D array. Always remember. Now, what if I want to access this 4 here, the value 4? How do we do that? You can see that the value 4 is in the second row, and then the first column is at the intersection of the second row and the first column, which I am trying to indicate with the movement of my mouse here. That is the intersection. So you specify these two indices, and then that is how you'll be able to access the value 4. So let me show you how to do that. So you say data, and then it is on the second row, which means 0, 1. So I go to row 1, and then it is on the first column, and the column also start counting from 0. So if I do this, then I get the value 4. Okay, so you give two indices to access individual items. Otherwise, if you give just one index, it is going to give you the entire row stored at that particular index when you count along the row axis. Okay, great. So let's see how we will be able to access 5 here. How can we access this item 5? The way to do that is to see on which intersection of row and column it lies. So this is on row 1 and then column 1. So if I do data row 1, column 1, then I'm going to get 5. Okay, so just as you are able to access individual values from the array and also access the entire rows, you can also be able to change the values in there. And thankfully this is Python, and we're also using Jupyter Notebook, so we can try things out to see if they work at all. So what if we want to change the entire row 1 to have zeros? Okay, let's try something and see. So I'll say data row 1 is equal to 0, and let's see if it changes what is in data successfully. And indeed it does. So what happened here is these are the advantages you get with Numpy, the vectorized operation. If you wanted to do this with vanilla Python list of lists, you have to use a for loop or list comprehension, but Numpy understands these things. It is a vectorized implementation of the common operations that we perform on lists. So I said data 1, which means for row 1 I want you to set everything to 0. Okay, now how do we slice, just as we did with the regular 1D Numpy arrays? How can we also slice 2D arrays? Okay, let me show you something. So if I do data and then I say 1 to the end, what do you think this thing is going to give me? Let's run it and see. So when I do data 1 to the end, because there is no comma here, I am still providing just one index, and because of the colon, it is a slice. Okay, so what happens is it starts from row 1 all the way to the end. I didn't specify the end, so it started from row 1, which is 0 0 0, all the way to the end, which is 7 8 9. So this is going to slice from row 1 all the way to the end. Okay, what happens if I do data, let's say 0 to 2? What do you think is going to happen? So this starts from 0, and like I explained to you in the 1D array, the last index is exclusive, so it is always going to slice up until 1 less than what you specified. So this is going to give me row 0 up until row 1. So I get row 0, which is 1 2 3, and then row 1, which is 0 0 0. And remember that every slice in an ND array also returns an ND array. Okay, so now we've learned how to successfully slice through the rows. How do we slice through the columns? Just as we did over here, if you specify one index, then you are slicing along just the row. So this slice along the row. But if you specify two indexes, then the first one represents the row index and the second represents the row column. The column index. In a similar way, if we want to do slicing, the first slice range that we specify applies to the row, and the second slice range applies to the column. So if I want to get the entire data again, I'll just say this and this. So what this means is that give me everything along the row as is, and give me everything along the column as is. Now, what if I just want to, I'm interested in selecting 1 2 0 0. So the 1 2 and then this 0 and this 0. How do you think we'll be able to do that? What we need to specify is the range of the rows and then the columns. Okay, so I'm going to do something like data starting from 0. Starting from 0. I can be explicit here, of course I can leave it out, but I'm going to be explicit here. Starting from 0 to 2, and then the columns are also starting from 0 to 2. Let's see what we get. So we get exactly the subsection of the array that we are interested in. And the reason why this returns 1 2 0 0 is because we said along the row as is, we want from row 0 to row 1. Always remember that the last index that you specify doesn't apply. It is always one less than what you specify. This is always a big source of confusion and trouble for beginners, and so that is why I am reiterating and reinforcing it so that you get it once and for all. So once you specify 0 colon 2, it means the first two rows and then the intersection of the first two rows and the intersection of the first two columns. That gives you this, this, and then this. Okay, now let's go ahead and then try to change the values here and see. So I'm going to copy this slicing code here, and then I'll set it to, let's say, 5. Now let's go ahead and print data, and let's see what we get. So you can see that apart from slicing to get the values, you can also slice to change the values. So what happened is I have been able to change what is in here by saying slice from row 0 to 2, intersection with row column 0 to 2, and then you set that to 5. Basically, this is how you set values using slicing. Okay, now to help you understand things better, let's go ahead and then do some more slicing operations. So let's say we want to get these things here. So 0 0 8 and then 9. How are we going to do that? So we start by saying data, and then we look at on which row do we want to start. Of course, we want to start from 1 all the way to the end, so we are free to leave it empty. And then it is at the intersection of column 1 all the way to the end. So I'll say column 1 all the way to the end, and then you can see that I get 5089. Yeah, sorry. So I was looking at 0089, but because of this change we made here, the values have changed. So it's actually 5, 0, and then 8 and 9. So this is basically how you select using 2D arrays. Always remember that the ending, which is what we saw here, where is this? So when you check for the ending of an ND array, it tells you how many indices you need to specify to access individual items. And always remember that as long as it's a 2D array, the first axis of your array is the rows array, and the second axis of your array is the columns array. So when you are indexing into it, the first index or range of indices that you provide is going to be applied along the array axis, and then when you bring a comma, you specify how you want to index along the column axis. This skills that you have learned here applies to 3D arrays and n-dimensional arrays. So I would want you to practice as much as you can and understand things before moving ahead onto the next video, because these are very critical skills that you need to have to succeed in this course. So thank you very much for watching, and I'll see you in the next video.